Hello again, this is Alan from SQL+, and in this video we are going to level up our SQL and data services built with SQL+. The source code for the project I am working in is available on GitHub, and I encourage you to explore that repo for additional tips and tricks to fully leverage these tools. If you recall, in the last video we built our first data service using SQL+, and while we did save time and the generated service performed as expected, we exposed quite a few problems with that service. Particularly, we are not doing our due diligence to handle field validation or exceptions. We could write code in our client applications to deal with those issues, but that runs the risk of introducing code duplication since this service may be utilized in many clients. Also, it makes a false assumption that the developers using our service are aware of the potential errors that could be thrown. Keep in mind, the primary goal when building data services is to provide the developers down the chain with robust, developer-friendly services that make their job easier. Here's our original SQL for our customer insert, and rather than going down the path of having single routines for insert and update, we want to consolidate these calls to what database developers would commonly refer to as an upsert. And this is probably a good time to start thinking about naming conventions as well. When building data services with SQL+, you're going to want to consider how to name those services in a consistent way. I like to choose names for services that reflect the desired action as it relates to the business. So rather than create a customer upsert routine, I will simply call this service customer save. And here's what our routine looks like prior to adding the semantic tags. We are passing the same parameters at this point. However, now, if we pass the value 0 for the customer ID, we follow the insert path and exit. Otherwise, we follow the update path. We've also surrounded the execution with a try-catch so we can handle our exceptions as well. So let's put our semantic tags to use. Since we know there are no nullable columns in our table, we want to enforce that, which we can do with the required tag. Next, we want to enforce string lengths on our variable length parameters, and we have several options here. We can use string length, which allows us to set minimum and maximum lengths, or we can use min length and or max length together or independently. For this case, I'm going to use max length since that makes the most sense, and to complete our parameter validation, we are going to add the email tag to our email parameter. Next, we want to fix the parameter mode on our customer ID. If you recall from our previous video, input parameters get encapsulated in our input objects, and output parameters get encapsulated in our output objects. To override this behavior and make our customer ID parameter available on our input and output objects, we use the in-out tag. And with that in place, our parameter validation is complete, but we still have a few more options available to us. If we run our Razor Pages app and try to submit the form that is bound to our input object, the error messages are using the property names verbatim, which is the default behavior. We can use display properties to override this behavior and provide error messages more suited to end users. To do this, we make use of the display property tags. Add the tag for display, and worth noting, all of these properties are available using reflection, but few people actually use them, so they are all optional with the exception of the name. So we can remove the other ones and set the name to the desired value. Now when we submit our form, we see the desired values in the error messages. And finally, since we want our services to be as easy to use as possible, we are going to add some comments to our parameters using the comment tag. These comments will be available to other developers through IntelliSense, making our services self-discoverable. And that takes care of our parameters. We can now utilize the isValid method on our input object to check its valid state. And if the input is not valid, the validation results collection will contain a list of any errors present. If we think about the possible outcomes when executing this procedure, There are actually 5 possibilities. We can have the success paths for insert and update, a not found outcome on the update, a unique index violation on the email column, and a foreign key violation on the customer type column. To convey these different outcomes in a consistent and meaningful way, we use the return tag. This tag allows us to provide an enumeration back to the caller as to the exact outcome of a given call. This information can then be used to dictate program flow. If we go down the insert path and are successful, we return inserted. If we go down the update path, we use the row count to check that a row is modified and return either not found or modified. In our error handler, we check for a unique index violation, and if present, we return duplicate. And we also check for a foreign key violation and return foreign key violation in that case. If an unknown error occurred, that would indicate that something really bad is going on, and we have no choice but to throw that error back to the caller. Worth pointing out here is that the return tag has 2 arguments. The first is the constant value for the enumeration, and that value must be a valid C# identifier. The second argument is a description, which ends up being a comment on that enumerated value. Also, you may notice I'm using a bit of a convention here where success paths start at the value 1 and increment, while the unsuccessful paths or errors start at 101 and increment. This is just a convention I've adopted and recommend to the SQL+ community, but any integer will work, and if you want to adopt a different numbering scheme, that is entirely up to you, though I would encourage you to be consistent when choosing the number part of the enumeration. With our return tags in place, we can build our data services, and we now have access to the enumerated values back in our client application, and any developer using this service can see exactly what happened and determine program flow accordingly. Semantic tags are a real game changer for SQL developers, and in this video, we saw how to use them to make our data services more robust and more intuitive to use. Our generated services now have built-in validation, comments for self-discovery, and enumerated return values to convey the exact outcome of our calls. And that's pretty cool. This is Alan from SQL+. Thanks for tuning in, and have a great day.